Hi there once again. Okay, now we're going to look at chapter 3 on the core, not the core 2, the S1 book. Alright, the Edexcel S1 syllabus. Alright, the interquartile range. Okay, we're going to learn about the interquartile range there. Alright, first I'll just show you what the procedure is, and then I'll explain what this really means. Okay, right, now you know what the median is. Median is the person in the middle. Alright, in any data set, the person who sits in the middle, and the person who has a value who's at the middle, that's the median value. Alright, interquartile range though, you'll have to work out the person who sits quarter of the way through. So let's say you are measuring heights of students, okay, and these are the heights, and you arrange them in ascending order. Alright, so okay, so there are 20 people here. Alright, so the person so let's make it 21, which makes it better, yeah. 21. Alright, so the person right in the middle is the 11th person, isn't it? So 1 2 3 4 5 6 7 8 9 10 11. So that person there is the median. Oops, I lost it. 1 2 3 4 5 6 7 8 9 10 11. This person here, so the 11th person, so that person's height is the median value. It's the median. Alright, now the lower quartile. Alright, now you'll have to find out the lower quartile to work out the interquartile range. Is a person quarter of the way through. So there are 21, so the 6th person would be the quarter of the way through. 1 2 3 4 5 6. Okay, so that's the lower quartile. So whatever height that person had, okay, that would be the lower quartile value. The upper quartile is 3/4 of the way down. So if I add 5 to this, 1 2 3 4 5, so that's the upper quartile. Okay, so that's 16th person. The lower quartile is a 6. Now how I got these positions, again, it's 21 divided by 2, I get 10.5. I round up, so that's 11th for the median. If it's for the lower quartile, I do 21 divided by 4 because I'm looking at quarter of the way down, so that's 5.25. Again, I round up, which is the 6th. Okay, and 3/4 of the way down, 21 times 3/4, which is 5.25, added 10.5, 15.75. again I round up, 16th person. Alright, so this is how I figure out these positions. Okay, so let's just say the value that I had for the height was 104, and for the 16th person the height was 117. Therefore the interquartile range, I can just say its IQR is 113. Okay, so the interquartile range is the difference between the upper quartile and the lower quartile. Alright, so you can show it like this as well. Alright, good. Now let's see what actually this interquartile range means for a data set. Okay, what does the interquartile range mean? Okay, right, now let's just say for a certain class, a certain grade 3 class, okay, the heights of all the students had a median. Okay, so had a median of 115. Alright, and had an upper quartile of 107 and a lower quartile of 123. Okay, alright, so let's say there were 80 students here in this class. Okay, rather big class. Okay, 80 students. Okay, so the person right in the middle, like the 40th student, would have this height, 115. Alright, now a person quarter of the way through, the 20th student, has this height. Person 3/4 of the way through has this height. Okay, so 50% of the students have a height between 107 and 123. Okay, alright, for a different group of students, again we'll say there are 80 students here. Let's say the median is same. Alright, 115, but this time the upper quartile, oops, sorry, I should have called this the lower quartile, beg your pardon, and the other one the upper quartile, sorry. Alright, for this group of students, the lower quartile is 100 and the upper quartile is 132. Alright, okay, so the person quarter of the way through who's at the low quartile level, okay, the 20th person would have a height of 100, the 60th person would have a height of 132, the person halfway through, the median, is he has a height of 115. Okay, so 50% of the students, the middle 50%, have a height which varies from 100 to 132. Okay, so the middle 50% for this 107 to 123, the median is here at 115. The median is 115 for this as well, but the middle 50% for that group though has a larger variation. Okay, so this is what the interquartile range helps us to determine. Okay, if the interquartile range is bigger for a certain data set, okay, same sort of thing that you're trying to measure, you could say that data set has a larger variation than the other. Okay, whereas here the interquartile range is smaller. Okay, the interquartile range is actually 16. Okay, IQR is 16 here, whereas IQR here is 32. So there is larger variation. Okay, in this group than this. Okay, now you would think, okay, to work out variation, why can't I just go for the range? Okay, which is the difference between the smallest and largest and the smallest value. Okay, now the danger with going for a range would be, now let's say for this group of students, the lowest value was height, in terms of height, was 80, and the highest is 130. Okay, all right, and the highest here is 140, and the lowest here is 70. Okay, now I'm trying to show you something. Okay, I've just changed that value to 160. Okay, there's an anomalous result. There's a giant in the grade 3 class, 160. Okay, the lowest height is 80. The highest height here is 140. The lowest height here is 70. Okay, so the actual range here would be 80. Here the range would be 70. Okay, now you would think this shows more variability because the range is bigger. All right, but just because one or two extreme values are present, you're getting a bigger range here. All right, whereas you're better off choosing the 25th, the person at the 25th percent level and the 3/4 of the way level. You're better off comparing those values to work out, to give you a better picture of the variability than looking at the extreme values. Okay, all right, because you know, it depends where, all what depends is where this person was. If this person was in this class, you get a bigger range for this class. Okay, so that one person affects the whole sort of range of the class, okay, of heights. Okay, so it's better for you to look at the interquartile range because extreme values aren't affected with the interquartile range. Okay, and it's a better representation of spread. Okay, spread of data. All right, so that's why we go for the interquartile range and not the range itself, okay, which could be affected by extreme values. Okay, now let's see how we can calculate the interquartile range for just a group of numbers. Okay, just numbers like this. All right, but you'll have to arrange them in ascending order, just like you would have to do for the median. All right, so there are 13 numbers here: 1 2 3 4 5 6 7 8 9 10 11 12 13. So for the lower quartile, you divide it by 4, you get 6.5, that's 3.25. Okay, so you round it up, so that's the fourth person is the lower quartile. So 1 2 3 4, so the number 4 itself is the fourth person. Okay, and then for the upper quartile, you divide 13 by 3/4, or you multiply 13 by 3/4. You get 9.75, which is the 10th person. Okay, you round up, So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is 6, the value. Okay, so that's the 10th person. So the 4th person is 4, the 10th person is 6, so therefore the interquartile range is the upper quartile minus the lower quartile, which is 6 minus 4, which is 2. Alright, so this is just for random numbers. Okay, now you could get group data as well. Okay, so if you get something like this, alright, you'd follow the same steps that you did to work out the median. Okay, you would have to now so that you have 13 people in total. Again, the lower quartile, the person in the lower quartile is 3.25, so that's the 4th person. So basically the same data here that I've just put it into a table. Okay, so you're going to get the same numbers. Okay, but I'll do it anyway. So 4th person is 1, 2, 3, 4. So the 4th person will be in this category. Okay, so that's number 4. The upper quartile is 13 times 3 by 4, which is a 9.25. So therefore you got to go 9.75. Beg your pardon. You got to go for the 10th person. So that's 1, 2, 3, 4, 5, 9, 10. 10 is 10th person has a value of 6. Okay, and the 4th person has a value of 4. So here again the interquartile range is 2. Alright, you could also get a group frequency table where the categories could have a range of values. Okay, alright, so if this was a table here, just as if you would do it for the median, you would have to do linear interpolation to pick out the specific value for the median. Alright, so this has 22 in total. Alright, so therefore the lower quartile would be 22 divided by 4. Now if it's group frequency, you needn't round up, okay, your results. Okay, you just go for the 5.5. Okay, you don't say, oh, I'm going to go for the 6th. You don't do that. Okay, you only do it for the other two. When you get a frequency table like this, where the categories are just discrete values, or just a listed numbers like this, okay, where you got to round up that position if you got a decimal value. Okay, here though, because you got 5.5, you just stick with that. Okay, you don't round it up. Okay, alright, so you're looking for the 5.5th person. Okay, right, now 5 people are in this category, so you're going to look at the 0.5th person in this category. Okay, the 0.5th person in this category. Okay, so that has 7. Alright, so let's do the triangle thing again. Okay, that has 7. So I'll put the 7 here, and then the red one shows a smaller triangle. So that's the 0.5th person, and then that category has a class width of 9. Nope, it's not 9. You got to consider 19.5 as the lower class boundary and 29.5 as the upper class boundary, because there are gaps in between classes, isn't it? Okay, because so a person having 19.6 would be in this, person having 19.4 would be in this. So the actual class width is actually 10, because the class width is 29.5 minus 19.5, which is 10. Alright, so that's 10 there, and I've got to figure out what x is. Okay, so I've got to equate the ratios between the two sides. So the ratio between this and this is the same as between this and this. So 10 divided by 7 is equal to x divided by 0.5. Okay, so that's 10 divided by 7 is 0.7 times 0.5 is equal to x. Therefore x is equal to 0.35. So I've got to add 0.35 to the lower boundary, which is 19.5. So the lower quartile value is 0.85. Okay, now let's look at the upper quartile. The upper quartile is a 16.5th person. Now where is that? Okay, 16.5. So you've gone past 12, so 16.5th person will be in this. That's 12, so therefore that's a 4.5th in that category. Okay, so you have 6 in that category. Okay, so therefore that's the 4.5th person in that category for the small triangle, and the class width is 10, and you are trying to figure out x. Okay, so therefore x is equal to 7.5. I've got to add that to the lower boundary of that class, which is 29.5. okay, so I've got to add 7.5 to the 29.5, which is equal to 30.